Okay, picking up where we left off. Now that we've learned to mount a disk, we need to figure out how to unmount a disk. It's about as simple as you might think. You're going to do the unmount command. Kind of simple. Now, there's two ways you can do this. One would be what's called the lazy way, and that means I'll say I want to unmount, and I'm going to use the -L option. I'm gonna fake it here. I'm not actually going to type it because it would require us to do and all the rest of the stuff. So anyway, I'm going to say umount -L, okay, for that particular device. And by the way, in the umount command, it's kind of cool. You could umount by device, or you can, most likely you would unmount by the mount point. It just makes it a little easier, right, to be able to choose which one you want. Okay, cool. So if I did like public, that would so lazy means what I'm doing is I'm saying the next time someone leaves finishes writing, then I want to unmount it. In other words, don't kill anybody who's in the middle of doing their homework. Just wait. And so however long that takes, as soon as the last person is no longer using the disk, it's going to drop off. Now, how long is that going to take? I don't know. So maybe that's not exactly the way to do it every single time. So there's a -F option. F means force, which means I don't care if you lose your stuff. We're going down. So we're going to unmount that guy immediately. Now, a really cool thing that you can do, I'm not going to hit that return. One of the things you can do before you run an unmount, you might want to see how many people are actually using the thing. Wouldn't that be kind of cool? Well, there's this really cool thing called fuser. Fuser, like file system user. And if I do -C and I tell it I want to go to public, this will tell me the number of people. Oh, cool. Oh, sorry. Not a capital C. Anyway, there's not going to be anybody on there because I'm the only one and I'm not currently in there. Cool. So this tells me how many people are actually using the file system. So before you force them off, you might want to call them on the phone and say, "Hey, man, you need to get off that public folder because I need to take this guy down." Right. So in addition to the L option, which is really kind of cool, or the fourth option, you could use this to call them up on the phone and say, "Hey, dude, I need your help. You need to get the hell off." Okay, now let's go back and look at some of okay. Let me ask you a very strange question. Does the mount point for a disk have to be an empty folder? In other words, could I have, I could unmount the file, go to public, add some files, and then remount it. What's going to happen? Well, as soon as you run mount, it's going to graft onto the tree, and anything that was previously in the folder is just going to magically just disappear until you unmount it, and then it reappears. Now, this is a very sneaky trick that you could use to hide things. Okay, so hackers could use this, or maybe you want to hide your porn stash somewhere. You have a mount point, you put your stuff in there that you don't want anyone else to see, and then you just configure the machine to always mount a disk on top of it. So the files are there, they're intact, but there's just no way that you can get to them. Okay, kind of cool. Or creepy, depending on your point of view. So no, the folder does not have to be empty, but if it has stuff in it, it is completely unreachable until the folder is unmounted a second time. Okay, so there's an awful lot of these things that are aliases. If you go to page 125, they talk about remember when we did DF? Okay, oh come on, DF helps if you spell right. Okay, so there's an SDA2 and a so if I go look at this -AL on dev SD. Okay, so where's SDA1? I mean, I see it there. I see that 2 is root, but where is where is SDA1? Well, there's an alias for it. So it's a very common thing that the system actually goes in and creates kind of soup. So, for example, var and temp typically have their own file system, okay? And yet, we don't see in the devices there things like that. Okay, so temp typically has its own file system just because we want it to be, temp is completely different. It's not designed to be permanent. There's no, so when I boot the system up, it's going to wipe everything in temp and all the rest of that junk. So it can be looser, right? Like, I don't really care about the contents. I don't have to worry about file checking and all the rest of that stuff. So nobody runs FSCK, the file system checker, on temp. Because during a reboot, it's not going to be there. Okay, cool beans. So on page 127, they talk about the standard directories. I know we've already kind of sort of done a tour of this before, so I'm not really going to spend that much time. Here's, we talked about bin and dev and from another, when we were using the other book. So yes, this is kind of a tour of those things, and fine, take a peek at it in the book. It's pretty cool. All right, one more time. On page 126, they talk about the file types. You can see here in dev that all these guys have a B at the beginning of them. B means they're a block device. Keyboard would be a C for a character device. Block device, character device. So on page 126 is a bullet list. A regular file, duh. A directory, yeah, we know about those. A character device, which are almost always only going to be found in /dev. A block device, which is almost always going to only be found in /dev. And then symbolic links. We've talked about that before. We have hard links, which are really, really, really indistinguishable. They're just two markers in the directory that point to the same file. And a symbolic link is kind of sort of analogous to a Windows shortcut where it's not really there, it just points to where it is. Cool. Now we've talked about the file command before to find these things out. So if I said file dev sd, right? And obviously it's going to come back and say, hey, it's a block special device. Kind of cool. We've done this before, so I'm not going to repeat it, but it's the kind of a cool technique. It'll try to tell you, okay, this is a file, this is an executable, this is a whatever. Cool. We talked about hard links, so let's just go through it one more time. So the link command, the ln command creates what's called hard links. Now, here is a very strange scenario, so just bear with me for just a minute. Okay. A hard link means two things in the directory structure point to the same file. Now, typically that's not really a problem. Let's say I was counting files, okay? And so I have a folder called 1, and I have a folder called 2, and they have a hard link that all points to the same file called poem. So when I'm counting the number of files, it's going to go here and say, well, there's 1, and it goes over here and says, that's 2. Well, are there really 2 files? Not really. It's just 1. But, you see how that could be a little complicated if I was like trying to count how many files I have in my directory. When in reality, I probably have 1 less than the number of count because there's a hard link involved. Make sense? Okay. Now, let's get more complicated. Let's say, for example, I wanted to do a hard link on a directory. Ooh. Now, this could get really, really complicated. What happens if I have a link? So instead of doing it side by side like the example I just showed, what happens if I had a link here that a hard link in a folder and then hard linked it below it, somewhere below itself? Now, if I did that, then I could get like a circular loop. I would go into this folder and look for files, and go to this folder and look for files, go to this folder and look for files, and go back up to the top, and it'd go do over and over and over, and just be an endless loop. So hard links on directories is never, ever a good idea. And Ubuntu, in their infinite wisdom, said, hey, we ain't doing that. So it doesn't matter if you're sudo or not, you're not going to be creating a hard link to a directory. And the rationale is a little geeky, and hopefully I explained it fairly well. Okay. Now, another thing about hard links is hard links, because the file is being shared in two the directory listing is being shared on a single file, right? That has to happen inside a file system. If I have two file systems like I have now, I cannot create a hard link in my home directory that points to a file in the /public, because /public is not in the same file system, right? Because it's just one file with pointers, right? Point to it. Well, I can't do that because I'm not in the same file system. So hard links only work inside a file system. Again, that may not have been a perfect explanation, but if you read the book, it'll make sense. Okay. All right, we talked about symbolic links. Can I create a symbolic link to a file in public? Yeah, I can do that. That works. So let me do one just for the heck of it. So I'm going to go to public. Now I'm going to have to be root because I haven't changed the permissions any, but so just bear with me. So I'm going to do a oh dang it. Okay. I'll just do a touch on junk.txt. I forgot. I've got it. Okay, cool. CIS4335. Okay, cool. I'm just going to do a CHMOD777 on jump. Just so I can do something. CHMOD777 junk.txt. Cool. And then I'm going to edit that guy. Junk.txt. I can do that now, can't I? And then say, hello. Whoops. Okay, cool. Now I have a file in public. Yay! Cool. I'm going to go back to my home directory. And now I want to create a symbolic link to that guy. Okay? So I'm going to do an ln minus s. S means symbolic. And then I'm going to say a symbolic link. I'm going to call this one, I'm going to call it junk2.txt. And then I point to where the heck this guy is, public junk.txt. Oh. Sorry, I got it backwards. The source has to come first. And then the destination is junk2.txt. Yay! So now I have a symbolic link for junk2 that points. And let's just take a peek at it. So if I said cat junk2, I mean, by the way, I'm in my home directory now, aren't I? Junk2.txt, and ta-da! Okay, so yes, I can create a symbolic link, but not a hard link. Cool. All right, so file attributes on page 132. We've kind of sort of done this a bunch. We're going to have another chapter coming up. We're going to spend a lot more time on it. But the X, remember we had the RWX that you see in this listing here? The only X's that we see so far are the ones in directories. Now there is an X for executable. We haven't done shell scripts yet, but sooner or later we're going to create a shell script, which is an executable thing. It's sort of like a batch file if you were in the Windows world. You know, something.bat, and you just double click on it and it runs whatever heck is in there. Okay, so considering that, we don't have any of those, but we do have X's on those directories. So what the heck does execute bit mean in a directory? Well, what it basically means is that I will allow you to pass through the directory without having permissions on the directory. Now that sounds a little weird. Let's say I don't have write permission, right? I do not have write permission on /public. Nod your head. And yet I can still edit that file because the file permission supersedes the directory permission if there's an X. Cool. Okay, we're coming up on the 15-minute mark. You know what's going to happen.